Greetings of the day, dear students. In this video, we are going to discuss about the layout and operation of hydroelectric power station, and we will see what do we mean by hydroelectric power station, its definition, what is its purpose, and we will discuss what are the main components in its general layout, like the consisting of hydraulic structure, water turbine and alternator, and what are the different components we are having, like trash rack, head race, dam, penstock, surge tank, turbine, tile race and draft tube. We will discuss about the purpose of each component in its layout, what is the functionality of each component. All those things we are going to discuss in this video, and also we will discuss about the turbines, how they are classified based upon the direction of flow of water, and what are the different types we are having, like axial flow turbine, tangential flow turbine, radial flow turbine, mixed flow turbine. All those things we are going to discuss in this video, right? Yeah. Dear students, if you observe, the hydraulic power station is going to utilize the potential energy of the water which is located at a high level, right, for generation of electric energy, right. Water will be stored at a greater heights. At greater heights, it is going to have the potential energy, right. Now the stored water is allowed to travel and hit the turbine blades. By the time it is hitting the turbine blades, it is going to have both kinetic energy and potential energy, and along with that some pressure also will be there, right. Now all these forms of energy, depending upon the type of the turbine, it will be converted into the mechanical energy. Now the turbine shaft will be coupled to the generator shaft, where this mechanical output of the turbine will be converted to the electrical energy with the help of generator. So here three forms of stages we can observe. The kinetic energy and potential energy or some pressure energy is converted into mechanical energy with the help of turbine. Now with the help of generator, this mechanical energy is converted into the electrical energy. So that is what it happens in the hydroelectric power station. In that process, if you observe the layout, the components can be divided into hydraulic structure components, the components related to the hydraulic structure, water turbine and alternator. So here, as we are familiar, this alternator is going to convert the mechanical energy into electrical energy with the help of alternator, right. Now this turbine output will be the mechanical energy. If you observe, we are going to have a dam, we are going to have an anchor block, penstock, a surge tank, a turbine, tile race and draft tube, and also we are going to have a spillway. This is also one of the component of the hydraulic structure, right. So these are all the different components we are having in the hydraulic structure. If we observe, the purpose of the water reservoir is to store the water, right. In order to store the water, we need a reservoir. So reservoir is going to store the water, right. In order to run the prime mover and to produce the electrical power, this storage of water is required. That storage point we are going to call it as water reservoir, and which stores the water during the rainy seasons, right, and supplies the same during the dry season, right. Now here the other component is the dam. its function is to provide the required amount of head or height. If you increase the storage level of the water to the higher heads, it is going to have more and more energy, right? So it helps to increase the working head of the plant. Depending upon the construction, low head plants, medium head plants and high head plants, like that we are going to have, right? If you observe the trash rack purpose is to filter out any waste materials that is going to damage the dam gates or turbine runners, right? So that those waste materials are to be filtered out using the trash rack component. Now coming to the forebay, it is a large body of water just upstream of the penstock. Now this forebay is going to act as a regulatory reservoir, right, storing the water temporarily when the load on the plant is reduced, and it is going to supply the water when the load on the generator is going to increase suddenly. So it is going to distribute the river water to the various penstocks, and it is also known as head pond. It is also known as head pond. Forebay is also known as head pond, right? Now you can observe the another component, surge tank, right? Here we are having the surge tank. This is the surge tank, right? Just before connecting to the turbine, we are going to have a surge tank, and the penstock is there. Here you can observe the penstock is there, right? Now the purpose of the surge tank will be, it is a large cylindrical tank which is going to provide a high head and medium head, right? The surge tank is to be usually provided for the high head and medium head plants, right, between the dam and the powerhouse, right, in order to regulate the flow of water depending upon the load on the system. If the load is fluctuating, if the load is decreased, right, it is going to store the water, and if the load has increased suddenly, then it is going to supply the extra water to the penstock, right? Now it also going to control the pressure variations in the water which are going to result because of the rapid variations in the water flow, right? It is going to control the pressure variations in the water, right, and thereby it is going to prevent the water hammer effects. So the purpose of penstock is, it is going to store the water when the load is decreased, or it is going to supply extra water, right, to the penstock when the load increases suddenly, and also it is going to control the pressure variations in the water, right? Coming to the penstock, this is the pipe which is connected between the surge tank and the turbine, that is called the penstock, right? It is going to supply the water to the turbine from the surge tank or forebay, and generally it is made up of steel or concrete, right, and it is designed as a pressure flow pipe, and this penstock will be supported with the help of the anchor blocks. So the water that is going to be flown to the turbine will flow through this penstock. This is the pipe which connects the surge tank and the turbine, right? Now coming to the spillway, this is to be considered as a safety valve for the dam, because it serves as a discharge of excess water from the reservoir. If any excess water is there in the reservoir, that excess water will be discharged with the help of this or through this spillway. It is going to discharge the excess water from the reservoir, right? So these are all the different components present, and next one is the water turbine. As we discussed earlier, this is going to convert the energy of the falling water into mechanical energy. Now depending upon the direction of flow of water to the turbine, it is classified as axial flow turbine, tangential flow turbine, radial flow turbine, and mixed flow turbine, right? If it is axial flow turbine, right, the flow of water will be parallel to the axis of rotation of the runner. If we are going to have a runner right? For that runner, we used to have the axis, and the water flow will be parallel to the axis of rotation of the runner. Example of such kind of turbines are propeller turbine and Kaplan turbine, or will come under axial flow turbine. If it is tangential flow turbine, the flow of water will be tangential to the path of rotation of the runner. Example is Pelton turbine. In radial flow turbine, right, the flow is radial to the path of rotation of the runner, and the flow remains in the plane normal to the axis of rotation of the runner, and the example is Francis turbine. Whereas coming to the mixed flow turbine, in this turbine the water enters the runner at the outer periphery in the radial direction, right, and it is going to leave the runner at the central in axial direction. So such kind of turbine we can call it as a mixed flow turbine, and the modern Francis turbine is an example of a mixed flow turbine. So these are the four different types depending upon the direction of flow of water we are having. Now sometimes depending upon the action of water, we can also classify them as impulse turbine or a reaction turbine, right? In impulse turbine, what happens is all the available energy of the water is converted into the kinetic energy or velocity head by passing it through the nozzle, which will be provided at the end of the penstock. Water travels with high velocity through the nozzle, which will be provided at the end of the penstock. Then such kind of turbine is to be called as impulse turbine. Example is Pelton wheel turbine. But whereas in reaction turbine, the available energy of the water will remain in the form of pressure energy. Will remain in the form of pressure energy. Now as the water flows through the runner, right, the pressure energy will be gradually decreased, and therefore the runner must be enclosed in a airtight casing. Airtight casing. Examples are Francis turbine, propeller turbine, Kaplan turbine will come under a reaction turbine. And another classification also be given depending upon the head. Depending upon the head, in the dam, right, at what height the water is stored, the head of the water, right, is maintained at what height, whether it is maintained at, if it is less than 15 meters, if it is less than 15 meters, such kind of plants are to be called as low head plants. If the height or head of the water is 15 to 70 meters, it is to be called as medium head plants. If it is 71 to 250 meters, it is to be called as high head plants. 250 meters and above, it is to be called as very high head plants. Now depending upon the height of the or head of the water stored, right, sorry, depending upon the height or head of the water stored, right, if it is low head, propeller or Kaplan turbine can be used. If it is medium head, we can use Kaplan or Francis, or if it is high head, Francis or Pelton, and if it is very high head, we can go for the Pelton wheel turbine, right. Now coming to the draft tube, after water have done its useful work, right, the water is to be let out, right. It is a pipe or passage of gradually increasing cross sectional area, right, where its area of cross section will be slowly gradually increasing, right, which connects the runner exit to the tile race. It finally it will be connected to the tile race, where we are going to have the runner exit. If you are having the runner, its exit will be connected to the tile race with the help of this draft tube. And one more thing is, very important thing is, the lower end of the draft tube must be submerged in the water, should be submerged in the water below the level, should be submerged below the level of the water in the tile race. It should not be exposed to the outside. It should be submerged below the level of the water in the tile race, right. So this is the draft tube we will be having, and it is going to permit a negative or suction head to establish the runner exit, and this makes it possible to install the turbine above the level of the trial race level without any loss of head, right? Yeah, and it is going to convert the large proportion of the velocity rejected from the runner into useful pressure energy. That is, it is going to act like a recuperator of pressure energy. Recuperator of pressure energy, right? Yeah. Now coming to the alternator. Now this alternator is going to convert the mechanical energy into electrical energy, right? And now as we are discussed in the DC machines and AC machines, right, where we have discussed about the DC generators. In the AC machines we have discussed about the synchronous generators or alternators, right, where we are going to have the stator part and where we are going to have the rotor parts, right. In this context, it is going to have a salient pole type machine, right, large number of poles with large diameter and short rotor length. Now the speed of this rotor will depend upon the speed of the turbine, because the turbine shaft is coupled to this shaft of the rotor, right. So here the speed of the generator is going to depend upon the speed of the turbine. Again, it will depend upon the specific speed of the particular type of turbine we are using. Depending upon the type of the turbine, which turbine we are using, right, whether it is a propeller or Kaplan or Francis or Pelton wheel, right, depending upon the specific speed of the turbine, again this speed will depend. Again this speed will depends upon the specific speed of the particular type of the turbine. And the power output we are going to get from the generator will be at the voltage levels of some 3.3 kV or 5 kV and 11 kV, and it will be at 50 Hz frequency. It will be at 50 Hz frequency. Later on, this generated power at low voltage levels will be stepped up to the higher voltage levels for the transmission purpose, right. Once these at this voltage levels the power is generated, with the help of transformer, this voltage levels will be stepped up and will be transferred to the different locations, right. So this is the about the alternator. So if you observe, if layout of the hydroelectric power station is asked in an exam, right, dear students, this is the main figure to be highlighted, and we have to specify the function of each and every component. Right. Yeah, thank you.